So a few key pointers about statics. It's going to be very similar to dynamics. It's all about forces again. So we're still going to use F equals ma. The main difference though being that static means stationary, so the acceleration is always going to be 0. There'll often be more than one force that we're looking at, so we're going to have lots of simultaneous equation solving, and I just want to pick up on these two phrases and note those down and look out for them when the questions come along. So here's an example question. It says that the diagram shows a particle in equilibrium, so straight up we know that the acceleration is 0, and we're asked to calculate the magnitude of forces P and Q. We'll begin as usual by resolving in given directions, so I'm going to resolve first to the right. In this case, obviously as it's stationary, you can choose whichever direction you wish, either right or left, and I'll also resolve upwards. Pause the video now and try and do it by yourself. So I can use my equation 1 to find P. Rearranging will give us this, and keep it in trig for as long as you can. Now that we've got our value for P, we can put it into equation 2 and rearrange to make Q the subject. Making sure that as they're both forces, they're both given with newtons as either unit. Okay, so this time we've got an inclined plane. All of the forces are already labelled onto the diagram, so you don't need to add anything to it. What we do need to do is treat it like we normally would with an inclined plane, and we're going to resolve everything either parallel or perpendicular to the plane. So I've drawn my dotted lines on. Make yourself your own copy of this diagram and start highlighting what you think are the parallel and perpendicular components, then come and check back. Okay, this is where we're up to, so we'll start off by resolving. I'm going to go up the plane, you could choose down, it's got no acceleration. So the way that I've written it now, I've sort of started to give the game away a bit because I've done equation 2 first. If we now divide this term by this term, the p's will cancel out, and we know that sine alpha divided by cos alpha is equal to tan alpha. So then we're just going to have an equation with alpha in it. So we'll do equation 2 divided by equation 1. And just to get alpha by itself, then we'll then need to do the inverse tan of all of that. And that will give us an angle of 12.5 degrees, correct to 3 significant figures. Try and keep everything in terms of trigonometry for as long as possible, because that gives you the most accurate answer. Don't try and find decimal values for these two and then put it all together afterwards. In order to find P, we then need to substitute our alpha value back into one of our earlier equations, and you can choose whichever one you want to use. When you do that, it will give you a P value for that final force of 10.8 newtons, correct to 3 significant figures. To give yourself a little bit more practice, try redrawing a diagram similar to this and maybe changing some of the magnitudes of the forces. So perhaps change the 8, perhaps change the angle which the slope is at, perhaps change this force and this one, and check that you're still able to follow the procedure that we did here, particularly looking at this division stage which we went through there. That's all for this week.